Hello and welcome. In this presentation, we will look at time-driven activity-based costing with the help of an example. So we'll specifically look at costing customer deliveries using time-driven activity-based costing. And we will apply those steps that we have to consider for time-driven activity-based costing. So we're going to use time as a cost driver. So step one will be to estimate the cost per unit of time of a resource provided, which is in the form of people and or machines. So we have to use the equation cost per unit time will be equal to total cost of supplying activity capacity divided by practical capacity in time. So we look at all the costs that we have for delivery. And in this case, it's 14,114,333. That's the total cost. And we look at the number of trucks that the company has, number of weeks that the company operates, number of hours per week. When we multiply these three, we get the total hours per week. But out of that, only 80% is the capacity that is actually being used. And that is the activity capacity. So 0.8 times the product of these three is the practical capacity for this company, which is 179,520 hours per year. And we can convert that into minutes, as we'll see that in time-driven activity-based costing, we want to go as low a unit of time as possible. So 80% practical capacity when converted into minutes is these many hours multiplied by 60, and that gives you 10,771,200 minutes per year. So we can now find cost per unit of time by looking at the cost of 14,114,333 and dividing it by the capacity in minutes, 10,771,200, which gives us $1.31 per minute. Right, so that's the capacity cost per unit time. Now we go to step number 2 to identify attributes of a given activity and estimate their effect on unit time for that activity. So here we have to look for how these different customers for a company are different. In this case, for Cenac, you have home and garden, you have horticulture and agriculture. These customers could have very different requirements. And those are things which we need to account for and then construct a time equation. So here is, for example, a way in which we can look at it. We look at loading a truck, and it can be different between agriculture customer and retail customer in the form of paperwork, for example. 2 minutes spent on paperwork in the case of agriculture customer versus 5 minutes spent on paperwork for retail customers. There's uniform 10 minutes for setup, 10 minutes per pallet, irrespective of the type of customer. So there are some of these activities that we can see are different in terms of the time requirement for customers, agriculture versus retail. So we try distinguishing it with respect to loading the truck, transporting it each way, unloading it, and payment. So those are things that we will now have information about. This is something which we get from time study data. Companies nowadays have good technology systems many times to capture these times, and having that information can enable application of time-driven activity-based costing. Once we have these times and the associated activities that we have here, we will create a delivery time equation. So delivery time equation is 10 minutes for the setup plus 10 minutes per pallet. So number of pallets have to be multiplied to it. Plus, if it's an agricultural customer, then we'll have to take into account all the costs or all the times involved with respect to agriculture customers. So 2 minutes for paperwork, 2 minutes here, plus 1.5 minutes per mile for every transport. So 1.5 minutes multiplied by number of miles. And since it's each way, we'll have both ways. So multiply it by 2 plus 5 times number of pallets, that is your unloading. So we are taking that into consideration, and we do the same thing for retail. And if there is cash payment, there is 5 minutes involved. If it's credit payment, 8 minutes involved, and then return pallet, we'll have some time to spend on that, 2 minutes per pallet. So we are taking a time equation for delivery here. Right, so we then can look at individual customers that we have. So in this case, we have 4 customers, and these are differentiated based on agriculture versus retail. Look for how many pallets were shipped there, any packs if that was the case, miles one way, whether it was cash or credit, and look at the total time in minutes. The cost per minute we have already calculated as $1.31 as step 1. And then we find the delivery cost by multiplying the total time with the cost per minute. And we have 4 different values based on the attributes of these customers. Next step is to apply or allocate these activity costs to cost object based on consumption of time as determined by the time equation. So we have applied this particular cost for each of these customers. So that's how allocating this cost helps in understanding the diversity of the customers as against having a flat amount per delivery, which was relatively naive in terms of allocation. This does not distort customer costs. Some of the deliveries would be overcosted, some are undercosted, and this way, when we do the time-driven cost analysis, it captures the true resource consumption by customer. So this would be how we would apply it now, as against the naive activity-based costing where we had applied the same value across all customers. Now we will be applying it based on the specific customer type that we have. So we have differential values, and hence our profit margins are going to be different from what we had estimated earlier by simply using activity-based costing without considering the time. So that's how we can also extend it beyond delivery to also processing orders. So here's an example of things that are needed for processing orders. So we'll take into account all the durations that are provided. You can see in some cases, it's even going into seconds, the time in seconds for certain activities for processing, and create a processing time equation per sales order that you see at the bottom. We can do that same thing for picking an order and create a time equation for picking time per delivery. So we can create these equations for each of them and calculate, just like we did for delivery cost associated with processing sales orders and picking orders, and then allocate them to individual customers. And when we start allocating it this way, we'll start seeing that the profit margins are quite different from what we had estimated in the first place. In fact, the customer segment that we thought had the highest profitability is a loss-making customer segment now. So this is an important revelation which companies can use for their benefit. Now, what they learned here is that while this was what they thought the case might be with their current setup based on the accounting system, in reality, if they account for the activities and resource consumption, their largest customers were having losses here. They were providing 14% loss on sales. So now we are revealing true profitability for this company. And they realized that the home and garden was creating large loss. Horticulture was also providing losses. And that information is quite different from what they had thought based on just the accounting system. So this kind of information is valuable when companies have to rethink about their way to approach the market from supply chain standpoint. Thank you.